In this screencast, we're going to take a closer look at the Octet Rule, which is what governs how bonding occurs. So let's start by getting some definitions out of the way. A molecule is a neutral group of atoms that are held together by covalent bonds. A chemical compound whose simplest units are molecules is called a compound. So here in this diagram, you can see three different compounds. We have water, which is H2O. We have an oxygen molecule, which is O2. And then this is a sucrose molecule. So you can see that the molecules are all held together. They're all covalent bonds because the electronegativities between the elements are going to be such that it's a covalent bond. Also, we're dealing with nonmetals that are all being combined here. So that's why these are molecular compounds. A chemical formula indicates the relative numbers of atoms of each kind in a chemical compound by using atomic symbols and numerical subscripts. So a chemical formula for water is H2O. Chemical formula for sugar is C6H12O6. Those are the chemical formulas. Molecular formula shows the types and number of atoms combined in a single molecule of a molecular compound. So our octet rule says that atoms want to have 8 electrons in their outer shell. The reason is because noble gas atoms are unreactive, and the reason that they're unreactive is because their electron configurations are especially stable. The reason that their electron configurations are stable is because their valence or outer shell is full with electrons. So other atoms can fill their outermost A and P orbitals by sharing electrons through covalent bonding. And this bonding formation follows the octet rule. The octet rule says chemical compounds tend to form so that each atom, by gaining, losing, or sharing electrons, has an octet of electrons in its highest energy level. So if we look at our S and P orbital, recall that in your S orbital, we can hold a total of 2 electrons, and in the p orbital, we can hold a total of 6 electrons. So if we add them together, we get a total of 8 electrons between the s and the p orbital. And so the octet rule, octa stands for 8. Our goal is to end up with a full outer shell, full s and p orbitals with a total of 8 electrons. Like everything else in life, there are exceptions to the rule. Exceptions to the octet rule include hydrogen. Okay, recall that hydrogen forms bonds in which is surrounded by only 2 electrons. That is because hydrogen is in the first energy level. In the first energy level, there's only the s orbital, and the s orbital holds 2 electrons. So hydrogen has a full outer shell with just 2 electrons. The other exception is that there are main group elements in period 3. Okay, so pay attention, that's period 3 of the periodic table and up. And I know this seems confusing. Up means additional period, so period 4, period 5, period 6. But as you're looking at the periodic table, this is actually going lower on the periodic table. Okay, so when you get to row 3 or lower on the periodic table, they can form bonds with expanded valence, which involves more than 8 electrons. So our expanded valences are usually going to hold 10 or 12 electrons. All right, so just to review, we're talking about the octet rule, okay? And the octet rule says that we want to have a total of 8 valence electrons in our outer shell. Our exception to this is going to be hydrogen, which wants 2 valence electrons in its outer shell. And the reason we do this is for stability, okay? Also, you do want to remember that in row 3 and lower on the periodic table, that these elements can expand their octet to hold 10 or 12 electrons.